Ladies and gentlemen, let's welcome David Wang, President of the AI and All Scenario Intelligence Business Unit of Huawei Consumer Business Group. Distinguished guests and developers and colleagues online, welcome to attend this event, and welcome to Dongguan. I'm really delighted to be able to see you again on September the 10th, 2020, on this very venue. Harmony OS ecosystem took the first step in enabling ecosystem. On June 2nd, Harmony OS for mobile phone means the accelerated development of Harmony OS ecosystem. Richard just mentioned that they are now 155 million OnePlus 8 Huawei devices running Harmony OS, and now they are 60 million third-party devices. They are not running on Harmony OS, however, they are building with Open Harmony plus Harmony OS Connect, and they can also participate in the Harmony ecosystem. I believe this is the perfect beginning for any ecosystem, and I believe Harmony OS ecosystem will facilitate the coming of a smart and all-connected future. Just imagine if there are more devices available to us, and if we have to learn to use them as we learn to use smartphones, this might create an extra burden to us as we own more devices. The amount of applications for phones is at million level. In the future, with atomic services plus applications, there would be tens of million level, or even 100 million level, even billion level applications and services. With so many devices, so many applications and services, if we do not change the way people consume services, then we will not really enjoy the benefit of all connected world, because the operation on devices are far too complicated and it's not easy for us to access the services we want. So today I'm going to talk about how can we leverage AI technologies to redefine the interaction between man and device, and redefine how human beings can have access to digital information and services based on the Harmony OS ecosystem. I can give you an example. I believe as we improve our living standard, more and more people pay a lot of attention to our health, and more people exercise regularly. Then ideal result is that you want to have a coach, a professional coach, who can provide guidance and suggestions to me based on my body status. And this coach will remind me whether I'm working in the right way, whether it is doing good to my body, whether I am going to hurt my body or myself. And after the exercise, the coach will provide a way for me to relax myself. I believe everybody love exercising and sports would hope to have this kind of coach. With a Harmony OS ecosystem, this is something that will be made available to you. As we have more devices, each device can serve as a sensor. Take sports as an example. If you are about to start a workout, you have a body fat scale, which will be able to know your body status, and then my watch can know my sleep and also my heart rate. And when I choose a way of workout, those devices can work together to provide a workout plan. And during my workout, the device will monitor your posture, heart rate, and breath. And it will remind you to take in more air and take solid step. It's like a private coach. And after the workout, it will also provide recommendations for body and muscle relaxation. To facilitate your understanding, I would like to play you a video.
开始跑步，运动。
Start running. You can adjust the step frequency or change the posture. I believe through this video you will intuitively understand our vision of the future, how we redefine the interaction between man and machine. We no longer rely on having access to the service in the device-centric way. You will feel that you do not need to search for a service because the devices will recommend the right services to you based on your based on intent analysis. In different scenarios, there will be more sensors for you as you own more devices, and they can understand your intent in a better manner. This what I mean, how in the future we can redefine the man-machine interaction. And this is the kind of smart life and all-connected future that should be. I believe with Harmony OS, we will have more opportunities to build up a scenario-based super device. The more devices we have in the super device system, there will be more sensors available to record the user behaviors, and we can better understand users' intent. Let me explain in details how this technology is made possible. Now, consumers already have a lot of devices with many sensors. For example, location sensor, space information sensor. Some other sensors will record your biology information or metrics, and some other sensors may record different scenarios. Now, with only a single device and a single perspective of information, it's hard for the sensors and devices to understand the intent of the users. With multiple devices and multiple perspective of information, user intent can be better understood. To realize this goal, the key lies in how to access to such sensors and how to build up multimodal semantics, and based on that to understand the intent of users. There are a few key technologies. The first technology is that we know that when you have multiple devices, the major challenge lies in the heterogeneous structure. They have different sizes, different sensors, and the signals they use for communication are also different. If we are not able to have the same clock, let's say my voice print information and gesture can better show my intent. For example, if I would like to emphasize something, I may use a gesture to show this emphasis. This text plus my gesture, then my audience will know that I'm emphasizing this point. But if the clock of these two pieces of signal mismatch, then the result will be wrong. For example, if the voice in -1 minute is combined with the gesture at this very minute, then the intent will be judged in wrong way. Therefore, it is important to have a clock syncing, and we have the D-soft bus technology. The purpose is to have the soft bus capability almost online or on par with the hard bus or physical bus. The key is the soft clock. Each device, when they communicate with each other, important thing is that there's a crystal oscillator, and this crystal oscillator will provide the clock information, and all the modules will need to calibrate the oscillator. When there are multiple devices forming a super device, I will collect the clock information from the device with the strongest crystal oscillator, and then all other following up or subsequent processing will be based on this soft clock. The accuracy of this soft clock can be less than 1 millisecond. In Harmony OS 3, the latency will be less than 500 microsecond. This way, we're able to ensure clock syncing. A second very important thing is that is something that most AI experts could understand. If data is not labeled, then the data is meaningless and does not have any value. However, data labeling is time consuming and energy consuming. In many scenarios, the data cannot be labeled. To give you an example, if the sensor records the altitude and longitude of me and there's no label of the data, then this data is meaningless for me. So data labeling is a very challenging task in analyzing data with AI. Now we have a very innovative time alignment and label model data based on the other label data or label other data based on existing labels. We can use the existing label data and then add labels to the unlabeled data. As we have more devices, we will be able to substantially improve the automatic labeling efficiency. This is also a major innovation we brought today. And another very important thing is that if we want to leverage sensing signals, the sample size is very small with very limited data. Unlike we have a lot of offline data for semantic training. And another challenge is that the sensor may not be that stable. We cannot ensure that in all super device system, any device or all devices are stable. Once there is a fluctuation, let's say I have 10 devices, let's say 3 devices have problematic data, then such kind of errors cannot be tolerated by the model. That means if we are going to take this path, then we cannot use the existing traditional AI models for training. So we have generated the small sample size AI model. With this model, we are able to reduce the impact brought by small sample size fluctuation. We hope this way the models we trained from the small sample size can also be stable. And the core algorithm is called Sparse Coding. Or sparse encoder. This is the non-supervised algorithm. This is a very abstract, but I still want to explain a bit. It's to find a comprehensive vector signal, and I can use the array to show the vector signal. This way, I am able to ensure that the models will not fluctuate because of the sample size instability. This way, this technology is a must for us to train with a limited sample size. As we train the data, since the training happens on device, if the model gets bigger and bigger, then it will consume more hardware resources. And then other applications will have limited resources for operation. So we have an adaptive deployment technology. To put it simply, based on the total RAM resources, the model can make adaptive cutting or reduction so that the model can be deployed in the limited RAM resources. This model is applied to Syria with the combination of so many technologies, with the real-time data federation. We are able to understand the user's intent. And the next step is to provide recommendations of services based on intent. I believe there will be much more atomic services than the number of applications. I am confident that in 3 to 5 years' time, there will be hundreds of millions of atomic services or even billions of atomic services. With so many atomic services, if you have to search, download, install, and then get the access to the services, then it will bring trouble to users. With atomic services, can we just hand over this part of task to the device itself? That is what we bring to you. After understanding the intent of the users, how can we make sure the experience of accessing such services is simplified? This is the other key technologies we offer to you. They are some very vague concepts, and I will try to explain it to you. What do we mean by explicit structured intent? Let's take a sentence example. I want to travel, and the semantic is the explicit structure intent. Then what do we mean by implicit vectorization intent? Let's say I've never driven before. Then the device should exclude the scenario of self-driving travel. So based on the explicit structure intent and implicit vectorization intent, we can really better understand the real intent of a user. So with the sensor federation, we are able to enhance the implicit vectorization intent. This way, we can accurately capture such intent, plus the explicit intent, we can really increase the understanding accuracy. On the right-hand side, applications should also let others know what their intent are. For example, what is the roles of such applications? We can use images or text or any other means. Traditionally, with PC search, it's based on text matching. They use text to explain the meaning. For example, it may include title, abstracts, and the content. Now we have richer expressions or representations. How can we leverage those representations? This is very important for developers. If the intent representation of your apps is very accurate, then we can bring your applications to the users that need your service. We can project the two intents into a vector space for matching, and then we can ensure what users want is what we recommend. So this is the second step. We hope with implicit vectorization intent, we are able to just select maybe several or a dozen of application candidates based on the intent of the applications, and then based on explicit structure intent, we can just select a few applications and services out of the total scope so that we can provide what they need.
So if that is realized, we can redefine the human-machine interaction. So in the Syria suggestions of Harmony OS 2, that was the underlying technologies. We want to thank all the consumers for your love and support. We have a very high utilization rate for the Syria suggestion, and over 50% of the users no longer need to search specifically for the service after using Syria suggestions. Based on the time, position, and the scenarios, the possible services needed are all covered by Syria suggestions. So as you use it, you will be using search less. You do not need to go to various icons to find your applications because they are all in the Syria suggestions, and we will keep doing that. The purpose of doing that is to build a capable smart assistant that serves as a unified portal, which is Syria. Syria, hopefully, will shield all the hardware spec differences, and Syria will be able to demonstrate intelligence and find the needed service from massive amount of services. Once this objective is realized, we will fundamentally change the human-machine interaction and the information acquisition method. So what will Syria do in the future? Let me give you the scenario as an example. Let's say at home, in the living room, or rather in the master bedroom specifically, you will find Syria to help you do something. For example, the smart wake-up feature that remains a challenge today If you wake up Syria, you will be waking up accidentally a lot of devices. We have optimized a lot, but still we cannot achieve 100% accuracy. However, based on Harmony OS ecosystem, this is no longer top priority. We still, based on the multi-device collaboration and the mutual knowledge of the device's profile, we will know that who should I turn to if I cannot finish this task. If I want to watch a video and assume the loudspeaker respond to me, then traditionally this application cannot be done because the loudspeaker cannot play a video. However, in the Harmony OS ecosystem, this is possible because the loudspeaker knows that the digital TV next to it can play video. So the loudspeaker will transfer the instruction to the TV where the video is played. That is a transformative experience compared with today. If you talk to Syria, your services will be delivered in a closed-loop manner. Let's say it is late at night when you want to play the video, so that you will be watching it in your study room. Then, through the multi-device collaboration, the system will know that now the person is in the study room, and all these services and contents will be delivered or projected in the PC or the TV in the study room. This is what we envision for the future smart or connected interaction, where the machines understand me, the device knows me without I having to look for these services. That is our great milestone for the future connected world. Syria is not only used by Huawei itself, but is now being open to more partners. The Harmony OS has in its concept an openness ideology which is modularized and decoupled. So Harmony OS and the Open Harmony installed small devices can be installed with Syria suggestions. This also features flexible deployment. With Syria deployed on it, with the Harmony OS interconnection, then in whatever scenario, at whatever time, and through whichever device, Syria will know it, and based on your current location and time, display the information that you need. This will spare a lot of time and effort of the consumers and will spare the search and the logical assembly works. In a smart or connected future, we do need AI capabilities. We need the Harmony OS distributed soft bus capability to connect all devices, connect device and service, and connect all services as well as connect service and people. Through all this, we will truly power a smart or connected future. All these capabilities will be provided in Harmony OS Connect software package to our partners. Our partners can adapt it to their own device, applications, or services, and develop their own Harmony OS-based applications. For the consumers, all you need is talk to Syria. In 2021, Harmony OS Connect supports vertical apps on devices with screens. For example, an appliance in kitchen, then all the menu kitchen-related applications can be run on this device. And in 2022, we will support our wide range of apps on devices with screens, which is our ultimate pursuit. With this software package, we also need to consider the convenience and ease of use for developers. So on this slide is what we offer to the hardware partners. This tool will improve the productivity for all OEM partners with one-stop IDE. Let me give you some examples. The number one feature is that today, when we develop an application, we need Windows or Android. Then during the compiling, I need to switch to Linux and need to switch to other environments. for other purposes. This remains a headache for developers. But our version can converge all environments. Without switchover of environments, you can perform the development, compilation, and among all other steps. The second important feature is that when you develop an application and when you completed the software, you need to install it on the hardware. Our version provides the simulation capability, so you do not need to install the software on the hardware for the testing. You can do the debugging and testing immediately on this platform, and after that you can install it on the hardware. Number 3, there are a lot of different chipset tool chains and the platforms involved. There are very complex tool chain configuration parameters. One experienced expert needs to spend 2 days on the configuration. However, we have integrated all these configuration parameters in this tool. So this tool can help the hardware partners to complete the hardware product R&D in one stop. So I have a website on the slide. So you're welcome to go and download by 5 p.m. today. When this version is released, the hardware development cycle will be greatly shortened and reduce the hardware development difficulties. And we won't be content with it. We will keep improving on it. We will meet all the challenges on our own so that we can leave the convenience to the developers. For app developers, today, our latest version is available on this website. So by 5 p.m. today, you can go and download several key features here that I want to share with our developers. First, we are providing simulations to more devices, and bidirectional previews can be realized. So after a coding, you can see its implications on the hardware through the simulations. When you make modifications, all the code will be automatically generated. This will greatly improve the development efficiency. The second feature, we provide low-code development capabilities. Interested people will know that low-code development, which is very popular recently, in the West, they called it citizen developer. I'm not sure how do we say it in Chinese, but citizen developer is a recently popular concept. The objective of this concept is to make something that used to be professional more accessible and doable for ordinary people. So low code means that you can develop an application through simply drag and drop. Next one, distributed simulations. Once the apps run on the device, they will become much more complex. Once a fault occurred, I have no idea where the fault is. I believe all R&D engineers had bad memories about this challenge. You spend 1 hour on coding, but spend 5 hours on debugging. If we are able to save the debugging time, then the development will be much more efficient. So in this version, on the simulated device, you can operate cross-device applications. And during app hopping, you can have visibility of where the code is. This is something great for all developers because you have a clear idea of the fault location. You will know the related code and all the indicators, and you know where they are exactly. This will help you pinpoint the fault. Again, by 5 p.m. today, you're welcome to go to this website and download. We really wish to save the app and the service developers to save the development time and reduce the difficulty of development. Take a 5,000 line of code development as an example. We have reduced the time from 1 month to 15 days, next year to 7 days, and by 2025, 5 days, or even in 2024, 1 day only. So on this slide, based on all the capabilities that I have just mentioned, including the Harmony OS Connect software package, the tool platform, And the third-party Harmony OS devices with screens are all displayed on this slide. You are welcome to go to the HTC B4 exhibition area to visit all these devices. And more products will be released for the November 11 shopping festival in the Harmony OS Connect zone on VMall. Last but not least, ecosystem development is tough and challenging. It requires persistence and strategy, as well as the ability to withstand stress.